When working on the dust for a destruction shot, you can get a pretty good idea of how it looks in the viewport, but you really need to render it to dial in the final look and tweak the density and ultimately decide if the simulation is working well for the shot. Now here I've set up some geometry containers for the monster and the building proxy and the dust, and I've also created an environment light, which is a nice way to get some pretty decent lighting in the scene. I'm using this Shanghai environment map, and you can find some decent HDR textures freely available online. Now for this dust geometry container, I've just pointed this object merge to the null that we set up after the file cache for our sim. And we have a couple different options for shaders on this. So if we jump over to the material context, I've already dropped in a volume shader core and a pyro shader. I haven't touched any values yet. These are both just default values. And for dust, it probably makes more sense to just use the volume shader core. This has all of the settings that you would typically need to render the dust, whereas the pyro shader has a lot of options related to fire and explosions and those sorts of effects. But you absolutely can render some nice dust with either of those. In this case, we'll start with the volume shader core. So if we jump back to our geometry container, I've already pointed the material on the render tab to that volume shader core, and I've created a mantra ROP pointing to our render camera, and I've set the force objects to include the monster and building proxy and the dust, and I've set the force light to include that environment light. And that's all we need to set up to get some decent initial renders going, and if you render that with the default volume shader settings, you get a pretty nice image like this. Now the density of the dust can be a pretty subjective thing that can vary between personal preference and between projects. I've worked on films where they want a really heavy dust look, kind of like this, and I've also worked on films where they much prefer a lighter dust so that you can see more of the underlying geometry. And you certainly wouldn't want to resimulate every time that you simply want to tweak the density, so we can just do that in the material itself. On this volume shader here, you can just adjust the density scale to your liking. So now you can see if I turn the density scale down to 0.1, that dust is much lighter and we can see a lot more of the underlying geometry. And now if we turn that density scale back up to 1 and increase the shadow density scale to 3, you can see these shadows darkening in our volume. And I do really like this nice dense dust look, although this might be a bit extreme for this shot. We'd really need to render the entire sequence to judge. Now just for the sake of comparison, if we go back to the geometry container for our dust and we switch this over to the pyro shader, then you can see this is looking pretty cool, but this is rendering much darker, kind of like a really dense dark smoke. And of course you can compensate for that darkness in the shader, so if we bump up the smoke brightness, then it starts to look a bit closer to what we were getting with our volume shader. And Side Effects does have some fairly extensive documentation on all of these different parameters, including lots of example images, and I highly recommend that you review all of this information available in here to get a deeper understanding of all of the different parameters available to you when rendering volumes. Now I've also been using Redshift for a lot of my rendering, including my dust renders, and there are some things to watch out for when setting this up. So in the material context, you have an RS volume shader, and you need to connect that to a Redshift material. This Redshift material is what you actually apply to your dust geometry. You don't apply the RS volume directly. And this can be a little bit confusing because there is an RS material as well. You'll notice that this is different from the Redshift material. The RS material has no input to connect a volume shader, so make sure not to get those mixed up. Now I've set up some separate geometry containers for the Redshift render, and on the geometry for the dust, I've pointed that to the RS dust shader that we've just set up. And I'm using an RS light dome with the HDR image set to the same image that we used for the mantra environment light. However, one thing to watch out for in Redshift is that you need to specify at least one light to have a volume contribution in the scene. So on the Light tab, if you go down to this volume section here, you can just set that contribution scale to 1 so that it affects the volumes. And now if we look at an initial Redshift render, this looks like the default is maybe a bit less dense than the default was in Mantra. And of course we can adjust the material to compensate for that. And if you do try out rendering in Redshift, I'd highly recommend you check out their documentation as well, because they've also done a pretty good job at explaining all the different parameters on their volume shaders, and they've shown lots of example images with those varying parameters displayed. The most important parameters are probably scatter and absorption. Scatter is essentially like diffuse, and absorption is essentially transparency. And because the dust is looking a bit too light here, I'm going to increase the absorption coefficient to compensate for that. So now that's looking significantly more dense, and I'm also going to increase the shadow density scale on the Advanced tab. And that's starting to look pretty cool, although perhaps a bit too dark. So if we increase the scatter coefficient, we can brighten up that dust to compensate. And now this is looking like a pretty decent level for an initial render. Now it's also worth pointing out that we're currently rendering the dust with the monster in the building, but you would typically render the other objects in the scene as matte holdouts. So you'd really just get the dust and black everywhere else to allow for some flexibility in compositing. If you'd like to, you can also investigate deep rendering, which will embed extra samples in every single pixel at various depths in the scene. That allows you to render elements separately without rendering holdouts, and then you can still composite them together in 2D based on that depth information. And it is pretty awesome and flexible, but it does take a lot more disk space to store all that extra data. And in this class, I don't expect you to have time to render out the entire sequence, but I would highly encourage you to experiment with rendering all of the different layers that we've worked on in the class separately, and then compositing them together afterwards, and then tweaking them in 2D. It wouldn't make sense to render every single layer separately. I would probably include the monster with the building and the rebar and the glass panes, but I would probably do the glass shards and the glitter and the debris and dust all in separate render passes.